Hello students, today I am here to teach you the last geometry lesson in your O-level syllabus, that's Tangents chapter 22. So we'll see what are the theorems you need to learn in this lesson. Grade 10, you did some of the theorems. You need those theorems as well to do exercises. Now we'll take this diagram. We see a circle and a straight line, AB straight line. So here, when you look at these two figures, we see there are no common point to straight line and the circle. So it's not intersecting. So what can we see here? I can write there are no common points to the straight line AB and the circle. So this is the center O. When you look at this diagram, what can you see? There are two intersecting points with the line and the circle. So I'll label it as P and Q. So here we can see there are two common points. Two common points P and Q. I'll label P and Q. So points P and Q to the straight line and the circle. So this is the center O. Now look at this diagram. A circle and a straight line there, but we see only one common point. So we call, when you have one common point with a straight line and the circle, that's the tangent line to that circle. So the point where it touches we call point of contact. So in this diagram, this is the center. So this line, there is only one common point. P. I'll label this as P to the circle, to the straight line and to the circle. So we call this one as the tangent line. So in this lesson, we are talking about these tangent lines. So this line we call tangent. And the point, the common point, here we call point of contact. Now we'll see what are the theorems related to these tangents. So theorem number 1 in your textbook, it says the straight line drawn through a point on a circle. So this is a straight line drawn through a point on a circle and perpendicular to the radius through the point of contact. So when you draw a perpendicular, it becomes the tangent. So when you draw any line, and if you are drawing a perpendicular from the center, to that point, it becomes the tangent line. So remember, so this is the radius, but you have to connect the point of contact with the center. Then that line and this line becomes perpendicular. Now, what's the converse theorem? Converse theorem says the tangent through a point on a circle, this is the tangent through a point on a circle, is perpendicular to the radius drawn to the point of contact. So here also it says when you draw a tangent and a radius from the center to the point of contact, always those are perpendicular. So we'll apply this theorem in several examples. Example number 1, the tangent drawn to the circle with center A through the point B is CD. If BAD is 35 degrees, then find the value of x. So according to the theorem, we know when you draw the line from center to the point of contact of the tangent, this becomes 90 degrees. So that's the first thing we can write. So ABD angle is 90 according to the theorem. So we can write radius perpendicular to the tangent. Now look at this triangle ABD. So what's this angle? This is 90. Then these two add up to 90. So no need 180 because we have already 90 there. So you can easily take 35 plus x is equal to 90. So what's x? 90 minus 35. So you get 55 degrees for x angle. Look at example 2. In the figure, the tangent drawn to the circle with center O through P is AB. If OP is equal to AP, OP is equal to AP, OBP is 30. Find the magnitude of AOB. So we need this full angle. But according to the tangent theorem, we know the radius drawn to the tangent is perpendicular here. So this is perpendicular. So we can write down OPB angle is 90 degrees. Then what can you do? We can find out this angle. So this angle is 90 minus 30. PO. We'll write down the theorem. Radius is perpendicular to the tangent at point of contact. So POB angle is 90 minus 30. So you get 60 degrees for this angle. Now we need to find out this angle. Now look at OAP triangle. These two lengths are equal, means this is 45 and this is 45 because 90 divided by 2. So we can write down OAP angle or AOP angle. Both are 90 divided by 2. That's 45 degrees because of isosceles triangle. Now we found out this is 45. This is 60. So what's AOB angle? AOB angle is 45 plus 60. So you get 105 degrees. Example number 3. PQ is the diameter of the circle with center O. The tangents drawn to the circle through P and Q are AB and CD respectively. Show that PBQ angle, this one, and BQD angle, these two are equal. So what you know from the theorem? This is the diameter. PQ is the diameter. So diameter and the tangent, this is 90 degrees and this is also 90 degrees. PQ diameter perpendicular to CD line, PQ line perpendicular to AB. According to the theorem, radius perpendicular to the tangent. Then what can you say about these two? So allied angles, this is 19 plus 90, you get 180. Allied angles 180 means these two lines are parallel. So we can say PBQ angle plus OQD angle is equal to 180. Allied angles. So allied angles 180 means AB line is parallel to CD line. So if these two are parallel, what can you say about these two angles? These two are equal. Alternate angles are equal. So therefore I can write down DQ. I'll write BQD. BQD angle is equal to PBQ angle because of alternate angles. Exercise 22.1. In each circle given below, the center is O and AB is the tangent drawn to the circle through the point C. Find the value of each algebraic symbol based on the data in the figure. So look at the first diagram. This is the radius and this is the tangent. This is 90 degrees. First you can write OCB angle is 90 degrees according to the theorem. Radius is perpendicular to the tangent and it's only at point of contact, not any radius is perpendicular to the tangent. Now we can take the triangle OCB triangle. I can write x plus 30 is 90 degrees because this is already 90. So x is equal to 90 minus 30. You get 60 degrees. Look at the next one. Again, this is the radius and this is the tangent. This is perpendicular. So OCB angle is 90 degrees. And look at the OCB triangle or BCO triangle. We can write 2A plus 3A is 90 degrees because already 190 is there. So the sum of angles in a triangle is 180. So 5A equals 90. So A becomes 90 divided by 5. 18 degrees. Next part, you are asked to find out ABC. Look at this triangle, the OC and this line both are radii. These two are equal. So we can straight away write down A equals B. These two because of isosceles triangle. Then what's the next thing we can write down? This whole angle is 90 degrees because OC is perpendicular to AB tangent. Then we can find out the C angle using the triangle OBC triangle. This is 30 and this is 90. So what's C? 90 minus 30. That's 60 degrees. What can you say about this triangle? This angle is 30. So the other two equally divided. So we can write down A or B equals 180 minus 30 divided by 2. Because when you add A, B and 30, you get 180. So 180 minus 30 is 150. Divide by 2, you get 75 each. Look at the next one. OD and OC both are equal, radii. OD is equal to OC because of radii. Then if these two are equal, if this is x, this is also x. Now look at the triangle. X, 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 all angles are equal. That's an equilateral triangle. So 3x is equal to 180. X becomes 180 divided by 3. You get 60 degrees for x. Now what's the other information we know? We know this is 90 degrees. OC is perpendicular to AB line because of the theorem. Radius is perpendicular to the tangent. Then how can we find out y? X plus y is 90. So y equals 90 minus 60. Y is 30 degrees. Next one. Again isosceles triangle. This length is equal to this length because of radii. So if this is x, this is also x. I can write down 2x plus 100 is 180. Sum of angles in a triangle. So 2x equals 180 minus 100, that's 80. X equals 80 divided by 2, 40. Now that's x. How can we find out y? OC line is perpendicular to AB because of the theorem. Radius is perpendicular to the tangent. So what's y? Y equals 90 minus x. X is 40. So you get 50 degrees. This one. These two are radii. This is equal to this. So if this is A, this is A. And also we know OC and AB perpendicular. We can easily find out A. So 2A equals 90. A equals 45. 90 divided by 2. Because OC is perpendicular to AB line. Then we found out A. This is 45, this is 45. So what's B? B plus 45 plus 45 equals 180. Sum of angles in a triangle. Then B plus 90 equals 180. B equals 180 minus 90. That's 90 degrees. Question number 2. In the circle with center O, in the figure, AB is the tangent to the circle through the point X. If the radius of the circle is 6 centimeters and YB is 4 centimeters, find the length of XB. So the radius is 6 centimeters. So OY is also 6 centimeters. So this is 6. And also we know that OX is perpendicular to AB line. That's the tangent and the radius. According to the theorem, radius is perpendicular to the tangent. Now we can use Pythagoras theorem. So we need BX or XB, length XB squared is equal to, what's the hypotenuse now? 6 plus 4, 10 squared minus 6 squared. 10 squared is 100, 6 squared is 36. When you subtract, you get 64. Take the square root of 64 plus or minus 8, but we take the positive value because it is a length. So this is 8 centimeters for XB. Question number 3. The tangent drawn to the circle with center O through the point P is AB. Find the radius of the circle if BOP is 45 and BP is 6 centimeters. So similar to the previous question, earlier we knew the radius, but here we can put R for radius. This is also R. And what is given? So that's all given. So we know these two lines are perpendicular. OP line is perpendicular to AB line because of the theorem. Radius is perpendicular to the tangent. If this is perpendicular and this is 45, this is 45. Isosceles triangle. Now what can you say? This length should be equal to this length. So straight away we can write R equals 6 centimeters. I'll write down the reason. OPB angle is 45 degrees because of isosceles triangle. So that's how we can find out R. Question number 4. The tangent drawn to the circle with center O through the point B is AC. If OAB is equal to BOC, then show that AOB, this one, AOB is equal to BCO, this angle. What's the first thing we can do? We can write down OB is perpendicular to AC according to the theorem. So this is 90 degrees. I'll put this one as A and this is also A, because these two angles are given equal. So what is AOB angle? AOB angle is 90 minus A. Then according to OBC triangle, what is OCB angle? OCB angle is again 90 minus A. So these are equal. So therefore AOB is equal to OCB. So I'll write down this information also. OAB is equal to BOC angle, that's A. It's given in the question. So because of that, these two angles are equal. Question number 5. The tangent drawn to the circle with center O through the point P is AB. Q is on the circle such that OQP is equal to QPB angle. Show that OQ line and PO are perpendicular to each other. OQ and PO. So this is 90. But we know OP is perpendicular to AB line. This is the radius and this is the tangent at P. What can you say about this one? If we put A, this one, what's this angle? Or I'll write B here. What can I write about A plus B? A plus B is 90 degrees. And we know these two lengths are equal. OP is equal to OQ radii. Because of that, this is also B. But what can you say about OQP angle and this one? These are equal given. So A equals B. According to this one, A is equal to B. If A equals B, I can write down these two are equal. So this becomes 2A. So 2A, this is also A now. 2A from this equation, 2A becomes 90 degrees. A becomes 90 divided by 2, 45 degrees. This is also B. So this is 45, this is 45. You get POQ angle is 90 degrees. So if this is 90 degrees, because 45, 45, this becomes 90 degrees. So 90 means perpendicular. So you get a perpendicular line. So we can write therefore. So therefore PO line is perpendicular to OQ. So when this is 90 degrees, we can say PO is perpendicular to the OQ line. Question number 6. The tangents drawn to the circle with center O through the points A and B intersect at point C. Show that AOBC is a cyclic quadrilateral. What you know? This length is equal to this length, radii. OB or BO equals OA, that's radii. and this is the tangent. So this is 90 degrees and this is 90 degrees. OA perpendicular to AC, OB perpendicular to BC because of the theorem. Radius is perpendicular to the tangent. Now they are asking, show that this is a cyclic quadrilateral. Look at these two angles. These are opposite angles. Opposite angles add up to 180. When opposite angles add up to 180, that's a cyclic quadrilateral. So we can write CAO angle plus CBO angle, that's 90 plus 90 becomes 180. Those are opposite angles. So opposite angles 180 means AOBC is a cyclic quadrilateral. Question number 7. Two circles with equal radii and with centers A and B are shown in the figure. Y is situated such that AY is equal to YB. So this length is equal to this length. Show that YX is a common tangent to the two circles. Look at the triangle. We know AY equals YB. It's given. So if that means this angle is equal to this angle because of isosceles triangle. YAB angle and YBA angle is the same. That's isosceles triangle. Then what can you say about this one? It's not mentioned, this is the tangent. Just two circles with equal radii and with centers A and B are shown in the figure. Y is situated such that AY. So nothing given about this one. Equal radii means this length is equal to this length. Equal radii. Now we can first check the two triangles. We are checking whether these are congruent. Then easily we can show that if these two are congruent, these two angles are equal and it becomes 90 degrees. So we'll do that. Take AYX triangle and YXB triangle. YX is common. AY is equal to YB and YAX angle is equal to YBX angle. So because of these three, we can say AYX triangle is congruent to YXB triangle. What's the situation? Side, angle, side. Here we have this also. You can apply the common length also, either SSS or SAS. Both are okay. I'll put SAS. So because of that, we know that the corresponding elements are equal. AXY angle is equal to, these two angles are equals to YXB angle. corresponding elements. Elements are equal. So these two are equal means each one 90 degrees. So we can write AXY or YXB is 90 degrees. So therefore, that's a common tangent. Therefore, YX is a common tangent because tangent and radius both are perpendicular. Question number 8. In the given figure, AB is a diameter of the circle and PQ touches the circle at the point B. Prove that QRB is 90 degrees. It's easy because AB is the diameter what you know about this angle? ARB angle. ARB angle is 90. Why? It's the semicircle angle. Semicircle angles are 90 degrees. Semicircle angle. If this is 90, this is a straight line, this is also 90. So QRB plus ARB is 180 because of a straight line, straight angle. So what's QRB? So QRB is 90 degrees because this one is 90 degrees. That's the first part. Second part, ABR. ABR, this angle, and RQB, this angle. You have to show that these two are equal. We'll put a letter here. This is A. If this is A and this is B, A plus B is 90. Now look at this tangent. This tangent and the diameter perpendicular. So this angle is 90 degrees. So we can write ABQ angle is 90 because radius is perpendicular to the tangent. Now take the big triangle. When you take the big triangle, what can you say about this triangle? This is 90, this is B. So what's this value? So we'll take C from ABQ triangle. I can write B plus C equals 90. Now according to 1 and 2, A plus B is 90, B plus C is 90. We can write down A plus B is equal to B plus C. Take both B out from the equation, you get A equals C. So this is A and this is C. So A equals ABR C is AQ, C is RQB. So these two are equal. Now we'll look at what are tangents drawn to a circle from an external point. So take this diagram. So this is a circle, this is the external point. So from that we can draw two tangents. So this is the point of contact. I'll write down A, and this is the other point of contact, B. This is the outside point P. Now we'll see how many tangents we can draw from an outside point. From this diagram we saw that's 2. Let's take any point outside. I'll take this point. We'll try to draw the tangent. From here we are trying to draw a tangent. So we can't draw like this. So only touches at one point. So we can draw one tangent like this. This is the point of contact. Now we'll take the ruler and see whether we can draw another tangent. Here you can't draw here, you can't draw there, you can't draw here. Only touches at one point. So here. So that's 2. So where's the point of contact? Here. So from any outside point you can draw 2 tangents. So we'll take another outside point. I'll take somewhere here. So we'll try to draw the tangent line from here. So take the ruler. Take the ruler from there and try to draw. Only touches at one point here. And again another one this way. Can we draw? Here. So here we can draw 2 tangents. So if this P is outside point, these are AB. So we can draw 2 tangents from one outside point. So this is another outside point and I'll label this is ML. So we can draw 2 tangents. So I'll write down P is an outside point and PB and PA are the tangents, 2 tangents drawn from P point. Here also, if you take any point outside P, these are the 2 tangents. So PA and PB are the 2 tangents to the circle from point P. Now look at this one. This is outside point is Q. So what are the 2 tangents? QM and QL. So I can write QM and QL are the 2 tangents drawn from Q point to the circle. So how many tangents we can draw? We can draw 2 points from an outside point. Now you get another theorem related to the tangents drawn from an outside point. So it says if 2 tangents are drawn to a circle from an external point, then the 2 tangents are equal in length. PA is equal to PB and the angle between the tangents is bisected by the straight line joining the external point to the center. So that means when you draw the line from here to here, this angle bisecting. Then the third point, it says the tangents subtend equal angles at the center. Here these two also, these two angles also equal. So we need to show this. So what is the method? If we can show that these two triangles are congruent, the corresponding elements are equal. So that's what we have to do. So we'll try to prove this. So data is the tangent drawn from the external point AB on the circle with center OR, AP and BP respectively. So what's the construction we need? So the construction is connect OP line. Now we'll take the two triangles, the proof. We'll take APO triangle and PBO triangle. What you know? We know OA is equal to OB because of radii. Same circle, radii of the same circle. Then what you know? Again, we know OP equals OP. That's common. According to the first theorem, we know that the radius and the tangent both are perpendicular. So these two angles we know. So we can write down PAO angle and OBP angle, both are 90 degrees according to the theorem. Radius is perpendicular to tangent. So we know this is a right angle triangle and one side and the hypotenuse both are equal. So we can say APO triangle is congruent to PBO triangle. RHS, right angled hypotenuse side, because of RHS. Then we can write down all these three information. So you can write down, therefore, APO angle is equal to BPO angle. And what's the next one? AOP angle is same as BOP angle. What's the third one? These two are equal, and AP, the two lengths AP and BP are equal because of corresponding elements are equal. So we prove that when you get a congruent triangles, all the corresponding elements are equal. So what are the corresponding elements? The two tangents are equal from an outside point. So, and also the angle at the center bisected by the point and the center joining straight line, and also the angle here from the outside point also bisected by the line connecting the point and the center. Now we'll try to apply this theorem also in examples and exercises. Example number 1. As shown in the figure, the circle touches the triangle ABC at the points PQR. If AB is 11, CR 4 centimeters, find the perimeter of the triangle ABC. What you know from the previous theorem? Tangents are equal. This length and this length equal, so this is also 4 centimeters. This length and this length equal, so I'll put X. This is X. This length also equal. I'll put Y and Y. Now we know AB is 11, so X plus Y is 11. What's the perimeter? Perimeter of ABC? AB plus BC plus AC. What is AB? AB we know 11 centimeters. BC? BC is X plus 4. Then AC? Y plus 4. Now, what can you see? X and Y there. X plus Y. We know X plus Y is 11. So, we can substitute there. 11 plus 4 plus 4 plus 11. What's the answer? 11 plus 11, 22. 22 plus 4, 26. 26 plus 4, 30 centimeters. So, the perimeter of ABC triangle is 30 centimeters. Example 2. As shown in the figure, the two tangents drawn from the external point C to the circle with center O touches the circle at A and B. The line drawn from the center O to C intersects the circle at D. Show that AD is equal to BD. According to the theorem, this is the tangent drawn here, this is the other tangent drawn here. We know that this is equal. So, if I put this is A, this is also A. And what else we know? We know that two tangents are equal. So, we can show that ACD triangle is congruent to BCD triangle. If these two are congruent, the corresponding elements are equal. AD equals DB. So, that's what we have to do. So, we'll take ACD triangle and BCD triangle. CD is common. And ACD angle is equal to BCD angle. That's A. And also I can write down AC is equal to CB. These two because of the theorem. Two tangents are equal. Equal in length and angle outside bisect by the line here OC. That's because of the theorem. Then what's this case? Side, side and the included angle. Therefore, we can write ACD triangle is congruent to BCD triangle because of side, angle, side. So, therefore, the corresponding elements are equal. So, therefore, we can write AD is equal to BD. Corresponding elements are equal. Exercise 22.2. The tangents through the points A and C on the circle with center O in the figure meet at B. If the radius of the circle is 5 centimeters and AB is 12 centimeters, then find the perimeter of the quadrilateral ABCO. It's already there. We know that AB is equal to BC. So if this is 12, this is 12. What's this? This is the radius. So easily we can find out the perimeter. So we can write down AB is equal to BC, that's 12 centimeters, and OC is 5 centimeters because of the radius. This is because of the theorem. Two tangents are equal. Now, just add it. The perimeter of ABCO is 12 plus 12 plus 5 plus 5. 12 plus 12, 24. 24 plus 10, 34. Unit is centimeters. Question number 2. The tangents drawn to the circle through the points P, Q and R on the circle AB, AC and BC respectively. Find the perimeter of the triangle ABC if RC is 6 centimeters and BP 5 and AQ 4. So, if this is 5, this is 5. Both tangents are equal. This is from the outside point. These two tangents also equal. If this is 6, this is 6. This is 4. So, this is 4. So, what they ask? Find the perimeter of the triangle ABC. So, what's the perimeter? ABC triangle. Perimeter of ABC is equal to 5 plus 4 plus 4 plus 6 plus 6 plus 5. 10, 10, 20, 30. So 30 centimeters is the perimeter of ABC triangle. Question number 3. The tangents drawn to the circle in the figure through the points B and C meet at A. BAC is 70 degrees. Find the magnitude of ABC, this angle. What you know about the tangents? AB is equal to AC. This length is equal to this length according to the theorem. Two tangents are equal. If these two are equal, if this is A, this is also A, isosceles triangle. So, A plus 70 is 180, isosceles triangle. 2a equals 180 minus 70, that's 110. A equals 110 divided by 2, you get 55. So A is ABC angle. So that's 55 degrees. Question number 4. The center of each of the circles shown below is O. The tangents drawn to the circle through the points A and C meet at B. Based on the given data, find the values represented by the algebraic symbols. In the first one, you are asked to find x and y. According to the first theorem, we know that this is 90, this is 90. So we can write OCB angle is 90 because radius perpendicular to tangent. That's the first theorem. So what's y? Y plus 55 is 90 because this is 90. So the sum of angles in a triangle is 180. So y equals 90 minus 55. So you get y equals 35. So this is 35. Then what's the other theorem we know? This angle bisect by the line joining the center and the point. So straight away x equals 55. According to the second theorem, angle at the center bisecting. That's the reason. Look at the second one. Again, OA is perpendicular to AB. This is also perpendicular. That's the first thing we can say. And these two are equal. Angle outside also bisect each other. So that's the theorem. So what's B? Straight away, B equals 30 degrees according to the theorem. So you have to write down the theorem. I'm just writing down just the theorem. So you have to write down angle outside bisected by the line joining the center and the point. If this is 30, what's A? A equals 90 minus 30. That's 60 degrees. Then what's C? C equals 90 minus 30. Or you can say these two also equal. A equals C. Angle at the center also bisected by the line joining the center and the outside point. So you can write 90 minus 30 or the other. So A is 60, C also 60 and B equals 30 degrees. This one, we can easily find out the angle B because this angle is equal to this angle. So bisecting the angle. So we can write down B is 70 divided by 2, that's 35 degrees according to the theorem. Then we found out this is 35 and also we know this is 90 degrees. The radius is perpendicular to the tangent. OC is perpendicular to CB. So therefore, what's A? When you take this triangle, this is 35. So A is 90 minus 35. So 55 degrees. Take this one. AOC. This one is 110. Angle at the center also bisecting by the line joining the center and the outside point. So if the whole thing is 110, what's y? 110 divided by 2. So 55 degrees. And how can we find out the other angle here? This is x, so this is 90. One angle is 55, so x is equal to 90 minus 55. So you get x as 35 degrees. Question number 5. O is the center of the circle shown in the figure. The tangents drawn to the circle through the points P and R meet at Q. If QR is equal to OR, show that PQRO is a square. So to show that it's a square, all sides are equal and each angle is 90 degrees. From the figure, we know that OP is perpendicular to PQ and also OR perpendicular to QR. Radius perpendicular to the tangent. So this is 90, this is 90. So opposite angles 90, opposite angles 180. So this is also 180 you get. And these two lengths are equal means we have to show that these two lengths also equal. What else we can say? This length is also this length because two tangents are equal. So PQ is equal to QR, but it's equal to OR as well. It's given. So we can say all sides are equal. Then all sides are equal and 90 degrees each. So we can write down this is a square. And also we can show if this is equal, this is 45, this is 45 and this is 45. So this becomes 45. So this is also equal. So using the angles also we can show that. So we can write down therefore PQRO is a square because all sides are equal and each angle is 90 degrees. Question number 6. AB and C are points on the larger circle and center O shown in the figure. AB and AC touch the smallest circle at the points P and Q. Show that APQ is an isosceles triangle. We know that AP equals AQ. That's the reason. Because two tangents are equal. Now we can see two lengths are equal. So therefore, APQ is an isosceles triangle. Second one, you asked to show BC is parallel to PQ. If this is an isosceles triangle, this angle is equal to this angle. I'll put A and A. So what's this angle? APQ angle is equal to AQP angle is equal to A. Now we know the OA, OB, OC all are radii. I want to do a construction. Just connect OP and OQ. Connect OP and OQ. What can you say about AOP triangle and OPB triangle? We can show that these two are congruent. So we'll do that. APO triangle and OBP triangle. Radius and the tangent 90 degrees. So this is 90 degrees. AB is perpendicular to OP. So APO angle or BOP angle, both are 90 degrees. And OP is common. And we know OA is equal to OB because of radii. So this is the right angle triangle and the hypotenuse and one side equal. These two triangles are congruent. You can take RHS, right angled hypotenuse and one side. Then we can say corresponding elements are equal. Therefore, AP is equal to PB. Corresponding elements. We can show the same thing on the other side. When you take AOQ triangle and QOC triangle, we can show that AQ is equal to QC. I'll write down similarly. AQ equals QC. Similarly, showing that these two triangles are congruent. Now what can you say about this? This is equal to this. This is equal to this. This is the midpoint of AB. Q is the midpoint of Q. Line joining the two midpoints. It's parallel to the third side of the triangle. So that's according to midpoint theorem. So we can write down, therefore, BC is parallel to PQ because of midpoint theorem. Question number 7. According to the information in the figure, show that XC is equal to CY. Also, AC and BC are the tangents drawn to the given circle at A and B respectively. So, if those are two tangents, we know that AC is equal to BC. Two tangents are equal. These two sides are parallel. That means this angle is equal to this angle. We'll write BAC angle is equal to YXC angle because of corresponding angles. And this angle is equal to this angle. But we know this angle is equal to this angle because of isosceles triangle. So this angle is also equal to this one. So from this information we can say XC is equal to CY because it's another isosceles triangle. So BAC is equal to that. I can write BAC is also equal to ABC triangle because of isosceles. Then that one is equal to this one. Now we'll take XCY triangle. CXY angle is equal to CYX angle. Then it's an isosceles triangle. So if it's isosceles, CX is equal to CY. Question number 8. The tangents drawn from the external point P to the circle in the figure touch the circle at X and Y. The line QR which touches the circle at Z is drawn such that XQ is equal to YR. Show that PR is equal to PQ. We know that PX is equal to PY. Two tangents are equal. XQ is equal to YR given in the question. Now add these two. 1 plus 2. PX plus XQ by PY plus YR. What you get? PX plus XQ is PQ. PY plus YR is PR. So PR equals PQ. The next one, QR. QR is equal to XQ plus YR. Look at the diagram. What is QR? QR is QZ plus ZR. QZ plus CR. But we know QZ is same as XQ. Why? Two tangents are equal. XQ because of XQ is equal to QZ. Instead of ZR, what can I write? YR. Because ZR is same as YR, tangents are equal. So you get QR equals XQ plus YR. Then third part, show that XY is parallel to QR. Now we'll mark all the information we know. We know this is this, this is this. And this length is equal. Px also equal. Px and Py both are equal. If these two are equal, this angle is equal to this angle. What's this angle then? 180 minus 2a. Now we can see this length and this length. We showed that PQ and PR both sides are equal. Now take the PQR triangle and PXY triangle. This is the common angle and both are isosceles. So what's this angle? This should be A and this should be A. 180 minus 2A divided by 2. So what can you say? These two are equal. Corresponding angles are equal means XY is parallel to QR. So that's what we have to write. So we'll write down all the information. Third part. PQR angle is equal to PRQ angle. These two angles are equal because isosceles. Then we can write down, when you compare PQR triangle, the common angle is 180 minus 2a. So what is PQR angle? We can do 180 minus 2a, that's the common angle, divide by 2. So you get 2a divided by 2, that's a. So we found out this is a, so therefore this is also a. Then we can write down RQX angle is equal to YXP angle, that's A. These two are equal. Corresponding angles are equal. Therefore, XY is parallel to QR. Question number 9. The tangents drawn through the points A and C on the circle with center O shown in the figure meet at the point B. Show that OAX triangle and OCX triangle both are congruent. We know that these two lengths are equal because of radii, and this is common, and the two angles are bisecting. The angle at the center bisecting. So two triangles are congruent. So we'll take the first one, OAX triangle and OCX triangle. OX is common. OA is equal to OC because of radii. And we can write AOX angle is equal to COX angle because of the theorem. Angle at the center bisecting by OB line. Now, according to this thing, you can say OAX triangle is congruent to OCX triangle because of side angle side. That's the first part. Second part, OB is the perpendicular bisector of AC. Now, we can show that these two angles are equal. Corresponding elements are equal. So, second part we can straight away write down AXO angle is equal to CXO angle because of corresponding elements are equal. Then this is equal, but this is a straight line. So I'll put A and this is A. This is A angle. So 2A equals 180. So A becomes 90 degrees. So this angle is 90. So OA, you can write down 90 means AC line and OB line both are perpendicular. So OB line is perpendicular to AC line. Then the third part, AOC angle is twice of ACB angle. This one, this and this. We found out this is 90 degrees. We'll put a letter here A. So this angle is 90 minus A because this is 90 degree angle. Then what can you say about this angle? So we need AOC angle. This angle. We need to show this is A, this is A. Here, can you see? This angle is 90 degrees. OC is perpendicular to BC. If this is A, this is 90 minus A. And this is also perpendicular. So this becomes A. And this is also A. This is A and this becomes 2A, double of that. So we'll write down OC is perpendicular to BC. That's radius is perpendicular to the tangent. If XCB angle is A, OCX angle is 90 minus A. This is 90 minus A. So therefore, BOC angle is A. Because again 90 minus A, 90 minus A becomes A. This is A, so therefore AOX also A. So what is AOC angle? AOC angle is A plus A, that's 2A, 2 times this A angle. A angle we can write down ACB. So AOC is twice of ACB. Question number 10. The tangents drawn from the external point Q to the circle with center O shown in the figure are PQ and QR. QO produce meets the circle at S. Show that PQS triangle, PQS PQS triangle and QRS triangle both are congruent. We'll take the two triangles and see PQS triangle and QRS triangle. We know that these two are equal. PQ is equal to QR. Tangents are equal. And SQ is common. This angle is equal. PQS angle is same as SQR angle according to the theorem. Angle bisecting. So, common length, two lengths and one angle. An angle is the included angle. So, we can say PQS triangle is congruent to QRS triangle, side, angle, side. Then part 2, 2OPX. OPX, this angle, and PQR, this angle, we have to show that's double of that. Okay, we'll take this one as A. So this is also A. We know that this is perpendicular. OPQ angle is 90 degrees because radius and the tangent both are perpendicular. So if this is A, what is this angle? 90 minus A. So when you connect this line, this is also 90 minus A because angle is bisecting by the line joining the center and the outside point. So what's the whole angle? 90 minus A. So POR angle is 90 minus A, 90 minus A. You get 180 minus 2A. Then what is this angle? OP and OR both are equal because of radii. So OP is equal to OR, radii. You get isosceles triangle. So what is OPX angle? OPX angle is 180 minus 2A divided by 2. 180 get cancelled out. 2A divided by 2, you get A. So OPX angle is A. What is PQR angle? 2A. So we can write down PQR angle is 2A. So 2 times A is OPX angle. So we can straight away write down that. Question number 11. As shown in the figure, Q is a point on both circles and QS is a tangent to both circles. The other tangents drawn from S to the two circles touch the circles at P and R. Show that PS equals SR. We know when you take the big circle, PS is equal to SQ because those are the two tangents drawn to the big circle. PS is equal to SQ Two tangents are equal. And also we can write SQ is equal to SR. That's also two tangents are equal for the smaller circle. So this is also equal to this one. So what can you say about these two? From 1 and 2, 1 equals 2. We can write PS is equal to SR. Part 2, PQR angle. PQR angle is SPQ. SPQ angle and SRQ angle. These two lengths are equal means this is A, this is A. These two also equal. We'll take this is B and this is B. So we need to find out PQR. So what is PQR is A plus B. What is A? According to the diagram, we can write SPQ instead of A. What's B? B, instead of B, we can write SRQ. So PQR, you can write down SPQ plus SRQ. So here I'll write down these information because you have to write down everything. SPQ angle is same as SQP angle is A. SQR angle is same as SRQ angle, that's B, because of isosceles triangle. Now we'll look at angles in the alternate segment. Look at this diagram. You get a circle and this is the tangent drawn to the circle at point P. And PQ is a chord. So when you take this angle, so if the tangent is AB, take this angle, QPB angle. What you call that? The angle in between the tangent and the chord. So we are looking at this angle and another angle in the alternate segment. What is alternate segment means? With this PQ chord, you get two segments, minor segment and the major segment. If you are looking at this angle, this side is the alternate segment. So this side is the alternate segment. Is the alternate segment to this angle. If you are looking at this angle, so think about AB is a tangent drawn to the circle at P and PQ is the chord. If you are looking at APQ angle, the angle between the tangent and the chord. So what's the alternate segment for that angle? That's this part. So we are looking at angles in the alternate segment. So that's what we are trying to do in this part. So what is alternate segment? Always you have to think about the angle, the chord, and angle between the chord and the tangent, and opposite to that we call the alternate segment. So we'll see what's the next theorem is about alternate segments. So the next theorem says the angle which a tangent to a circle makes with a chord drawn from the point of contact are respectively equal to the angles in the alternate segments of the circle. So basically what they say, if there's a tangent and a chord to the same point of contact, this angle, the angle between the chord and the tangent, is equal to the angle in the alternate segment. So something like that. So any angle drawn on the other segment, these are equal. Other way around, if you are looking at this chord, this angle, that means that's equal to any angle in the other segment. So any angle in the other segment. So we'll try to prove this. So you have given PQ is a chord and AB is a tangent drawn to the circle at P. Construction, you are drawing the diameter, this is the center, diameter PS and connect SQ. So we need to prove that. We'll take this angle, we need to prove that to be proved. QPB angle is same as PRQ angle. So this is the alternate segment. So this is equal to this. So we'll take this one is X, this one is A, and this one is Y. So we need to show that X equals Y. What do you know about the SP and the PB line? AB tangent is perpendicular to PS line because PS is the diameter. So radius is perpendicular to the tangent. Then A plus X becomes 90 degrees. And if you take this angle, what's this angle? This angle is also 90 degrees. Why? What's the reason? Because SQP is a semicircle angle. SQP angle is 90 degrees, semicircle angle. If this is 90 and if this is B, what can you say about A plus B? A plus B is equal to 90 degrees. So this is 1, this is 2. So A plus B also 90, A plus X also 90. So from 1 and 2, from 1 and 2, we can say A plus X is equal to A plus B. A get cancelled out and X equals B. X equals B. What do you know about Y and B? Y is also B. What's the reason? Same segment angles are equal with the PQ chord. So Y equals B is same segment angles. Then we can write Y equals B and X equals B. Therefore, X equals Y. So this angle is equal to this angle. So X is QPB angle QPB angle is equal to Q is equal to PRQ angle. So these two angles are equal. So according to alternate segment theorem, what is that? The angle between the chord and the tangent is equal to the angle in the alternate segment. Now we'll try to apply this theorem in exercises and examples. Example number 1. In the above figure, the line PQ touches the circle at A. Furthermore, BC and D are also on the circle. PAB is 55 and ADC is 120. Find the magnitude of BAC. BAC, this angle. What can you say about this? We know that when we take AC chord, this is the angle between the tangent and the AC chord. That's equal to angle in the alternate segment. That's 120. So what can you write? If this is x, x plus 55 is equal to 120. So what's x? 120 minus 55. So 65 is x. X is the angle we need. BAC. So what's the reason? You can write down alternate segment theorem. Example number 2. The straight line AB touches the circle at point P, Q, and R touches at point P. The straight line AB touches the circle at point P. Q and R are points on the circle. The bisector of the angle PQR, bisector meets the circle at S. So this angle, put X, this is also X. Show that PS is the bisector of the angle BPR. So PS is the bisector. So we have to show that these two angles are equal. If this is equal, bisector, those two are equal, what we can say about this angle and this angle? Both are equal. So we can write down according to the alternate segment theorem, PQR angle is equal to RPB angle. Alternate segment theorem. So this is 2x. And what can we say about this angle? Now take PS chord. So this angle and this angle both are equal. So if this is x, this is x. I can write PSB angle is equal to PQB angle. So that's x. Now this is 2x. So what is this angle? This angle becomes 2x minus x. That's also x. So these two angles also equal. So therefore PS is the bisector of BPR angle. So we can write this is x, RQ, RPS angle is 2x minus x, that's also x. So therefore we can see RPS angle is equal to SPB angle. So PS is the bisector of angle BPR. Exercise 22.3. PQ is a tangent to the circle through the point A. The points B, C, D, E lie on the circle. Angle between the tangent and the chord and angle in the alternate segment. So we need to find out equal angles. We'll first take BAQ. BAQ, this angle. To this angle, you get this angle is the alternate segment angle, and also we can take this angle. So we can write two angles, ACB angle or ACB angle or ADB angle. Then PAB. PAB angle. This angle. This is the other angle between the tangent and the chord. So that angle is equal to the alternate segment angle BEA. Next one, PAD. Now, other side. PAD is this angle. This angle is equal to either this angle, that's the alternate segment angle, or this angle. So you can write DBA. DBA angle or DCA angle. Now EAQ angle. EAQ angle is this one. What's the alternate angle to that? So this is the chord. So you get this angle. That's the only one. ACE angle. Now the other way. You have given the alternate segment angle and you are asked to find out the angle between the tangent and the chord. DBA. DBA. This angle. DBA is same as this one. We did that before. PAD. PAD. DCA. DCA. DCA angle. This one. That also we did. DCA. That's equal to this angle. PAD. DCA is same as PAD. Question number 2. In each of the following figures, AB is the tangent to the circle drawn through the point X. Find the values of represented by the algebraic symbols. You have given this angle is 40 and you are asked to find out X. So what is X? Straight away. So X is equal to 40 degrees according to alternate segment theorem. Second part, you are asked to find A and B. So here to this angle, this is equal because of alternate segment theorem. So A equals 35. And what about this angle? This B is the angle B here. So B equals 55, both because of alternate segment theorem. So remember alternate segment theorem, angle between the chord and the tangent is equal to the angle in the alternate segment. Part 3. Look at carefully, you are asked to find AB. A equals 45 straight away. What's the theorem? Same segment angles are equal. Then what's B? This B is the angle between the chord and the tangent. That's equal to the alternate segment angle. So 45. Fourth part, you are asked to find out X and Y. What can you say about X and Y? This is 60 means the alternate this angle is 60. So what is Y? We can use Y plus 50 plus 60 is 180. So Y plus 110 equals 180. Y equals 70. Subtract 110, you get Y equals 70. So this is because of alternate segment theorem. Then what is X? X is this one. Look at carefully the dx chord. This angle is same as this angle according to alternate segment theorem. So what is X? 50 plus 60. 110 because of alternate segment theorem. Next part, you are asked to find P, Q, R, S, all four angles. Straight away, we can find out P angle and Q angle. To this angle and this angle, both are alternate segment angles. So we can write P, Q, both are 30 degrees because of alternate segment theorem. Now to this angle, now we need to find out R. What's the alternate? The angle between the chord and the tangent? This angle. So if we can find out that angle, it's equal to R. So what is this angle? 90 minus 35. So R equals 90 minus 35. So 55 is R. Now we found out 55 for R, PQ we found. Now we need to find out S. Look at ED chord, this angle and this angle. So S is equal to 35. Same segment angles. So we found all the angles there. Now the next part. Look at carefully and see. I can straight away get A. A is 25. Alternate segment theorem. Then B and C both equal. And this angle and this angle equal. That's 40. So this is alternate segment theorem. And here 40 because of same segment angles. Now we found A, B, C. Question number 3. PQ is the tangent to the circle through A. If AC is equal to AB, show that CAP angle is equal to BAQ angle. CAP angle is equal to this angle, ABC angle, because of alternate segment theorem. But we know ABC angle is equal to ACB angle. ACB angle. This is because of isosceles triangles. So this is also equal. Yeah. According to alternate segment theorem, ACB angle is equal to BAQ. So this angle and this angle also equal. So according to this information, these two, when you take 1 and 2, CAP is equal to ACB, and when you take these two, we can say CAP angle is equal to BAQ angle. Part 2, show that PQ line is parallel to BC. We can easily see that the two angles are equal, that's alternate angles, so PQ and CB are parallel. So we take the second part. We can write down, we showed that CBA angle is equal to BAQ angle, and these are alternate angles and both are the same. So alternate angles are equal. Therefore, CA, CB is parallel to PQ line. Question number 4. AB is a tangent drawn to the circle through X. C and E are on the circle such that BXC and AXE is equal. It says such that BXC and AXE are equal. D is another point on the circle. Show that XD is the bisector. XD is the bisector of EDC. So that means we have to show that these two angles are equal. So we'll see whether it's true. This is A because these are given. If this is A, according to this one, this is A. Alternate segment theorem. This is A. So, according to alternate segment theorem, this is also A. So, we can easily say DX is the bisector of EDC angle. So, we'll write down AXE angle is equal to EDX angle, that's A. BXC angle is equal to XDC angle, that's A. Alternate segment theorem. Then we see, so EDX angle. Therefore, EDX is equal to XDC. DX is the bisector of EDC angle. Part 2. EX equals CX. EX equals CX. Now look at this diagram. ECX angle. What is ECX angle? ECX angle is same as this angle. This is A, same segment angles. So I can write that's equal to EDX angle. That's A. Other way around, this one, XDC angle is same as XDC angle. That's also A. Same segment angles. So this is also A. Two angles are equal. So this is an isosceles triangle. So EXC triangle is an isosceles triangle. So therefore, EX, the corresponding lengths are equal, opposite to the equal angles. EX equals CX. Third part, show that AB and EC are parallel. So we can see that this angle and this angle equal. Alternate angles are equal means the two lines are parallel. So according to the diagram, we see that ECX angle, ECX angle and CXB angle, both are alternate angles and equal. So therefore, AB is parallel to EC. Because alternate angles are equal means two lines are parallel. Question number 5. The straight line AB touches the circle at X. The chord PQ is drawn such that PQ is parallel to AB. Prove that BXQ angle is equal to AXP. Okay, so we'll first take this angle as A. This angle is same as this angle. Alternate segment theorem. These two lines are parallel. This angle is equal to this angle. So what they are? BXQ is the other angle. If you take this side, this angle is same as this angle. Alternate segment theorem. So BXQ angle is same as AXP angle. So first we can write down AXP angle is equal to AXP angle is equal to QPX angle, that's alternate angles. But we know QPX angle is equal to BXQ angle. That's alternate segment theorem. So these two sides are equal. So therefore, AXP angle is equal to BXQ angle. Now look at the second part. AXQP is a parallelogram if PX equals PA. PX equals PA. PX equals PA. These two lengths are equal. Then what can you say about this angle? This is A, isosceles triangle. And also, what is this angle? We know that these two lines are parallel and these two are equal. Here these angles are equal, so this length also equal. If we can show that these two lines are parallel, so that's a parallelogram. How can we show that that's parallel? Allied angles add up to 90. If we can show, what's this angle? This angle is 180 minus 2a. Now we'll see. This angle plus this angle, what's the value? You are getting 180. So allied angles 180, that means two lines are parallel. One side, opposite sides are parallel means that's a parallelogram. So we'll first write down PX is equal to PA. Therefore, PA PX angle is A. And you can find out XPA angle is 180 minus 2A. And also, according to the diagram, QX is equal to PX equals PA, and these two angles are equal, so we can write down PX is equal to XQ. So therefore, PQX angle is also A. Now we'll add the allied angles. XQP angle plus QPA angle. What you get? A plus 180 minus 2A. So A plus A, 2A minus 2A get cancelled out, you get 180. So allied angles 180 means QX line is parallel to PA line. And also, given that PX is equal to PA, and PX is equal to XQ. Therefore, PA equals XQ. So opposite sides, pair of opposite side equal and parallel. We can say that AXQP is a parallelogram. Question number 6. Two circles touch each other externally at X. YZ is the common tangent. AB is a chord of one circle. AX produced and BX produced meet the other circle at P and Q respectively. Show that BXZ, this angle, and XPQ angle, these are equal. So we'll take this angle and put A, that's the angle between the tangent and the chord. That's equal to this angle, alternate segment theorem. Now we'll write down the information there. BAX is equal to BXZ. That's A, alternate segment theorem. BXZ is same as YXQ. Opposite angles. This angle is equal to this angle. That's A. But what can you say about the other angle? That is also equal to this one according to alternate segment theorem. So we'll first write down this. These two are equal, therefore BAX angle is equal to YXQ angle. But we know YXQ angle is equal to XPQ angle. Alternate segment theorem. So we can write down, therefore, BAX angle is equal to XPQ angle. Now the second part show that AB is parallel to PQ. Obvious here, can you see? This is also, we found A. These two angles are equal, means alternate angles are equal. AB is parallel to PQ. So we can write down BAX angle is same as XPQ angle. That's A. Alternate angles are equal. Therefore, AB is parallel to PQ line. Miscellaneous exercise. First question. The tangents drawn to a circle with center O from the external point A meet the circle at B and C. If the radius of the circle is 5 centimeters and OA is 13 centimeters, find the area of the quadrilateral OBAC. We know that the radius and the tangent perpendicular. If we can find out the area of one triangle, multiply by 2. So to find out the area of the triangle, we need the length AC. This is the base. This is the perpendicular line. So we'll use Pythagoras theorem and find out AC. AC squared is equal to 13 squared minus 5 squared. 13 squared 169, 5 squared 25. When you subtract, you get 144. AC is square root of 144. That's 12 centimeters. Now we can find out the area of OAC triangle. What's the area? Half times base is 12, perpendicular height is 5. 30 square centimeters. So what's the area of quadrilateral OBAC? 2 times that, because you get same triangle here and here. So 30 times 2, you get 60 square centimeters for the full area. Question number 2. AB is the tangent drawn to the circle with center O, the point O through the point A. OB intersects the circle at C if CB is 4. It's given, and AB is 8. Find the radius of the circle. So this is R, this is R. And you know OA and AB perpendicular according to the theorem. Radius is perpendicular to the tangent at the point of contact. So use Pythagoras theorem. R squared plus 8 squared is equal to R plus 4 squared. Now open brackets. Square of first term, double of these two. 2 times 4 times R, 8R. Square of this one, 4 squared is 60. R squared plus 8 squared, you can write down 64. Now r squared get cancelled out from both sides. 8r is equal to 64 minus 16. So that's 48 equals 8r. R equals 48 divided by 8. So 6 centimeters is the radius of the circle. Question number 3. The centers of the two circles shown in the figure are P and Q. The two tangents drawn to the larger circle through A and B touch the smaller circle at X and Y, respectively. Moreover, these two tangents intersect at Z. Show that AX is equal to P, AX is equal to BY. We know that these two lengths are equal, same lengths, because these two are tangents. This length is equal to this length. So when you add it, you get AX equals BY. So we'll do that. AZ is equal to BC and CX is equal to ZY. Take this one, this is 2, this is because of tangents are equal. Now, when you add these two, AZ plus CX is equal to BZ plus CY. What is AZ plus CX? You get AX. What's BZ plus CY? That's BY. So you get AX equals BY. We'll do the second part. APZ is equal to YQZ. Here, look at this diagram. So these are two lines. So here, this angle will take A. This is perpendicular. So this becomes 90 minus A. This 90 minus A, this is also 90 minus A. This is also 90 minus A. Line drawn from the center to the outside point bisect the outside angle. So this is 90 minus A. And we know this is 90 degrees. So 90 minus A, this is 90. This becomes A. So that's what you have to do. So we'll write down YQZ. YQZ angle is equal to A, and that's equal to, we'll do step by step, and therefore YZQ angle is 90 minus A. And we know that's also equal to PZB angle. That's 90 minus A, these two. And these two are equal. So therefore, what's the other point? AC P angle is also 90 minus A. Now, according to the APZ triangle, what is APZ angle? APZ angle is 90 minus A. 90 get cancelled out, you get A. So you are getting same as YQZ angle. So we can write therefore YQZ angle is same as APC because both are A's. So I'll highlight this one. This is 1 and this is 2. Question number 4. As shown in the figure, the tangents PX and QX touch the circle at P. R, Q and S. The centers of the circles are A and B. Show that PR is equal to QS. It's easy. We know that PX is equal to QX. Tangents are equal. And for the smaller circle, we know that XR is equal to XS. That's also tangents are equal. We'll take this one as 1, this one as 2. We'll subtract these two. When you subtract, what happens? PX minus XR, QX minus XS. QX minus XX becomes QS. PX minus XR becomes PR. So PR equals QS. Second part, PQ is parallel to RS. PQ is parallel to RS. We'll take this triangle PQ RS, and this is X. In this diagram, we know PX is equal to QX. No? So this angle is same as this angle. And also we know RX is equal to RS. This angle is same as this angle. Now look at the big triangle and the smaller triangle. This is the common angle. Common angle is the same. So these two are isosceles triangle. So A becomes B. So if A is equal to B, these are corresponding angles. So these two lines are parallel. So that's what we have to do. So we'll take this diagram and write down part 2. PQPX angle is same as PQX angle, and I'll put A because of isosceles triangle. And also XRS angle is equal to XSR angle. I'll take B. Now we have to show that A equals B. This angle becomes, if you take this one, this is 180 minus 2A. If this is 180 minus 2A, what are these two angles? You get 180 minus 2A divided by 2. So you get A. So A equals B. So I'll write down PXQ angle becomes 180 minus A. Then what's XRS angle? XRS angle is 180 minus 180 minus 2a divided by 2. You get 100 here, 180 get cancelled out. 2a divided by 2, that's a. But we know XRS is b. So a equals b. So that means these two angles are equal. Corresponding angles. So QPR angle and SRX angle, both are equal. Those are corresponding angles. Corresponding angles are equal means PQ line is parallel to RS line. Now we'll look at the third part. AB and X are on the same straight line. We'll take the same diagram again and we'll try to do AB and X are on the same straight line. To show that it's on the same straight line, we have to show the angles they are equal to 180. So we'll just draw the radius here. R and B will connect. B and S will connect. And AP and AQ will connect. From the previous part, we took this one as 180 minus 2a. So what is one angle? 180 minus 2a divided by 2, that's 90 minus a. This is also 90 minus a. But we know this is 90 degrees. If this is 90 minus a, what's this angle? This angle is a here. And we'll take the big triangle. Big triangle, this is also 90 degrees. These are 90 degree angle. So if this is 90 minus a here, what's this angle? This is a. This angle a and this angle a we found. So what's this one? So this is 90 degrees. We can find out this angle from the quadrilateral. So we'll find out from the quadrilateral 360 minus a plus 90 plus 90 is this angle. So 360 minus a plus 180. So what's the angle? 360 minus 180, 180 minus a. So this angle is 180 minus a. This is a. When you add these two, what you get? We get 180. So we can write down ABR angle plus RBX angle is equal to ABR is 180 minus A. What's RBX is? A. Now add these two together, you get 180. So this is 180 means straight angle. So straight angle means ABX is a straight line. So we covered all theorems related to tangents and chords. So what are the theorems we did? We did the radius is perpendicular to the tangent, and then the converse of that, and the last one, when you draw two tangents from outside point, tangents are equal and the angle at the center bisect the center as well as bisect the outside angle, and also finally we did alternate segment theorem. So in alternate segment theorem we did the tangent and the angle between the tangent and the chord is equal to the alternate angle. So revise all theorems before your O-level exam.